Hi guys, welcome back to another video by TechMe Academy. This is part 1.5 called AC Sinusoidal Waveform Basics. We determined the crest factor, form factor, average value, and RMS value. So we're just going to go over this quickly.
We have our AC sinusoid, we have our peak values, we have our period, and our cycles. Okay, alright, so starting at 0 volts, this over here is time over amplitude. Over here, we can just look at it as time over amplitude. This amplitude peak is 100 volts. So the first question asks, derive the frequency. So how do we derive the frequency? Let's go and write the instantaneous formula quickly. E, which is instantaneous voltage, equals to Vp, which is the voltage peak, times sine, for the sinusoidal waveform, 2 pi ft. Alright, cool. Now we have the equation for instantaneous voltage values. Alright, I just want to express a few things here. We have our peak over here, which is our peak. Sine is sine. 2 pi represents a 360-degree rotation in radians. F is frequency, and that's time in seconds. Frequency again is in hertz. Alright. So if I give you this 100 over here is the peak of the waveform. This over here is just the waveform formula. And then this over here is expressed as 2 pi f. And this over here is time. So we have our value for 2 pi f, which is angular velocity over there, which is 314. All right. Now we can say 314 is also equal to 2 pi f, right? If you divide 314 by 2 pi, you get 50 hertz, approximately 50 hertz. All right, which is the frequency of the South African grid. So this is easy enough. Next question, we'll call this frequency question 1.1, and we'll go over to question 1.2 quickly. So we can take our angular velocity, which is 2 pi 50 times 0,015, and all of this, as I said, is angular velocity in radians. So the only modification we can make to just convert it to degrees is simple. We multiply it by 180 over pi to 270 degrees. Alright, so now we've taken our calculation from radians to degrees by multiplication with 180 over pi. So if I ask you, what is the angle in radians at 90? So 90 degrees is also equal to 90 times pi over 180. Alright, which is also equal to 1,571 radians. Right. So now we've done a question where we've converted from degrees to radians and then back from radians to degrees and vice versa in question 1.2 and 1.3. All right. Okay, guys, so the next question is to determine the time it took to get to 1.571 radians. So we have the internal value of this. So 0.571, and if we divide it by the 2 pi 50, then we get 5 times 10 to the power minus 3 seconds is what it takes to get to 90 degrees. Let's go and look at 1.5. Next equation, I just want to go with instantaneous current. So instantaneous current, you can say II, which is current instantaneous, is equal to I peak, very similar to the voltage equation, times sine 2 pi ft, right? All right. So remember, guys, calculators on radians, especially if you see non-degree values put into the equation. All of these are non-degree values. These are clearly radians. Put your calculator back to radians, and let's take an example here. Let's pretend that we have a current waveform that looks similar to our voltage waveform but with different values. And I tell you that peak to peak, I have 40 amps. Peak to peak, right? Calculate the instantaneous current after 10 milliseconds. If we have peak to peak equals 40 amps, then we have a peak is equal to 40 divided by 2. Why? Because peak to peak is that value we just wanted from the zero reference. The absolute value from the zero reference, which is divided by 2, which is 20 amps. All right, now we have our peak value that we can go and apply. We have IP, check. We've derived that from peak to peak. We have the rest of the value. Instantaneous value of current is 20 sine 2 pi. We made our new frequency 45, and t is 0.01, then equal to 6.18 amps is the instantaneous current. So this clearly demonstrates the ability for current to rise and fall, and we can demonstrate the formula to prove exactly what its value is and its angle is at an exact point. Thank you so much. Join for class 1.6 next.